So let us derive a mathematical expression for Newton's law of cooling. For that, let us consider a mass m. Let us consider a mass m at a temperature T. That is, the temperature of the body is T. Let T0 be the temperature of the surroundings. Since the body is hot, we have temperature of the body greater than temperature of the surroundings. Let C be its specific heat capacity. Specific heat capacity. Since T greater than T0, heat is always lost to the surroundings. Let, let Q be the heat transfer. Then from the Newton's law of cooling, we have rate of heat transfer dq by dt, proportional to the difference in temperature T minus T0. Always remember, since the heat is lost, we have to put a minus sign. So minus dq by dt, in order to remove the proportionality sign, you have to multiply it with a constant k times T minus T0. Let's call this as equation number 1. Now, for any body, if dq be the amount of heat transferred, dq, then that heat change or the amount of heat transfer will be equal to mc into dt, where dt means the drop in temperature or the change in temperature. For any body, dq equal to mc dt. If you divide the equation with dt, let's call this as equation number 2. If you divide equation 2 with the temperature, the time, change in time, then you get dq by dt is equal to mc dt by dt, where capital T is the temperature and dt is the change in time. Let's call this as equation number 3. Now, if you compare 3 and 1, you can put mc dt instead of minus dq by dt. That is, substitute equation 3 in 1. You get, instead of dq by dt, you can put minus mc dt by d small letter t is equal to k into t minus t0. Clear? Or you can write this equation as taking this t minus t0 to the left, you get dt by t minus t0 is equal to, taking all these terms to the right, that is minus k divided by mc dt. Clear? Taking all these terms other than dt to the right and t minus t0 to the left, the equation will be like this. Now you can call this one as another constant. Let's call that as a capital K, where capital K is equal to minus k by mc. Now, in order to get the temperature, you must integrate this equation. Let's call this as equation number 4. If you integrate this equation, you get dt by t minus t0 is equal to, let's call this as equation k, integral k dt. Now, let's call the initial temperature of the body is Ti and the final temperature Tf. At time t is equal to 0, the temperature is Ti, and after time is equal to a particular t, then the temperature is Tf. So the limit of integration for the term dt is equal to T initial to T final. Initial temperature occurs when time, here the variable is time 0 to a time t. Clear? Now let's integrate this equation. Now let's integrate this equation. We have integral 1 by x dx is equal to log x or log t minus t0. You have to put the upper and lower limit, that is ti to tf. Here you can take that constant outside and integral of dt equal to t, integral 0 to t. Now if you can replace this t with tf and ti. First you have to put the upper limit, log tf minus t0 minus log the lower limit ti minus t0 is equal to k, capital K, this one is capital K, k into t minus 0. Log a minus log b is log a by b, that is log of tf minus t0 by ti minus t0 is equal to kt. Now if you remove the log, you will get an exponent expression, an expression in the exponential form. Here actually there is e, so tf minus t0 by ti minus t0 is equal to e raised to kt. Or you can say log, if a log x is equal to y, which means that e raised to y equal to x. Here there is an e hidden in here, exponent. I'm just using that in here. So this whole term is the x and this kt term is the y. So e raised to kt equal to y. So the expression will be tf minus t0 is equal to, taking this to the right, ti minus t0 e raised to kt, or tf is equal to t0 plus ti minus t0 times e raised to kt. Now we have capital K is equal to minus k by mc. Therefore tf is equal to t0 plus ti minus t0 e raised to minus k by mc, small letter k, by mc times t. So this is the expression for final temperature of a body. Here this k, this constant k, small letter k, is a constant which depends upon the area of the body and the nature of its surface, nature of the body. Clear?